Hello everyone, welcome back to our third part of our Blender Geometry Nodes Rubik Cube Procedural Modeling series. In the first part, we created the basic Rubik Cube structure using geometry nodes. We use cube vertices, instance on points, face index values, position comparison and rotation instances to understand how one selected layer can be rotated. In the second part, we went deeper into controlled rotations. We introduced simulation nodes, stored rotation values using named attributes, created new rotation, old rotation and difference rotation logic, and used map range to achieve precise 90-degree turns. We also grouped the complete rotation logic into a reusable node group with side index and rotation value controls. Now in the third part, we are going to take that one rotation system and expand it into a complete Rubik Cube control system. A real Rubik Cube does not rotate only one layer. It must support rotations on multiple sides. So today, we will duplicate our existing rotation group and create 6 rotation controls, one for each side index. But while doing this, we will face an important problem. All duplicated groups initially use the same named attributes, which means they all share the same stored variable names, and because of this, the rotations interfere with each other. To solve this, we will learn how to generate unique attribute names dynamically. We will use string nodes, join string and value to string nodes so that each side index gets its own variable name, such as new underscore ROT0, old underscore ROT0 or diff underscore ROT0 and so on. After that, we will make separate rotation groups for the z-axis, y-axis and x-axis. We will connect the correct coordinate values for each axis and assign the correct side index mapping. By the end of this session, our Rubik Cube will be able to rotate along all 6 sides using geometry nodes. We will also test the rotation values and confirm that using multiples of 8 gives proper 90-degree Rubik Cube turns. This lesson is very important because it shows how procedural modeling is not only about creating shapes, it is about building systems, managing variables, avoiding conflicts, reusing logic and thinking algorithmically. So let us open the file from part 2 and continue building the complex 6-side Rubik Cube rotation system in Blender Geometry Nodes. Let us start by launching Blender. I will double click on the shortcut here. This will launch Blender 5.1.2. I am going to start by opening the file that we had completed in our previous session. It was this 2 Rubik Cube.blend file. If you are continuing from the previous session, you can open this file and start working on it. But if you have come to this video directly, in the YouTube video page or in the e-learning page, I have provided you with a link to the Patreon page, and if you go to the Patreon page, you can download this file and start working on it. So I will double click to open this file. Now in our previous session, we had created one single group of rotation. In this case, I want 6 rotation on the 6 faces of cube. So to create, I will come here into this first z-axis and I will set the z-axis value to 0 and the rotation also I will set it to 0. I want this to happen 6 times. For the first one, I have set the number as 0. Now I will select this z-axis, press Shift D to duplicate it, drag it and place it next. And in this case, I will set the side index value to 1. I will select it, press Shift D and duplicate again and place it next. Automatically it gets connected, and in this case I will set the side index value to 2. Then I will select z-axis, press Shift D and place it next, and in this case I will set the side index value to 3. I will middle mouse click and drag it, then again select z-axis, press Shift D and connect it next, and I will set the z-index value to 4. Then again I will select this z-axis, press Shift D and place it next. With middle mouse I will drag it and I will set the z-axis value to 5. Just by adding or changing the index value, I have to now test whether this is going to work correctly. So I will rewind it and I will play it. And if I change the rotation value, for example, to 4 here, you can immediately see that I have a bug. It keeps on rotating continuously. So I will stop the playback, rewind it, and I will set the rotation value back to 0. The issue we are facing here is when we have used named attributes, we have used the same variable in all these 6 node groups. However, for each node group, the variables need to be different. So now our next mission is to declare these variables with unique names for all the 6. How am I going to make these variables unique? I am going to just add the index number next to the variable name so that in each of these group I have a different variable. I will select the first z-axis and press tab on your keyboard. That group is going to open. I will press Ctrl space to make it full screen. Press N to close this sidebar. I have declared name attributes. The declaration is happening here. I have new underscore ROT, diff underscore ROT, and old underscore ROT. Now these names has to be unique for every group. How am I going to do it? I have to add this side index number to this variable. I will drag this group input to the left, and in this empty area, I will press Shift A, and in search, I am going to add string node. So you have input constant string. So I will add this string row, and in this string node, I am going to give it a name. For example, I will call it as new underscore ROT. Now next, for this string node, I have to add this side index value. So to join two strings, I will again press Shift A, and in search, select join strings. See, you have this join strings. I will add this. I'm going to drag this new underscore ROT string and connect it here. I have to add this side index also to this string, but when I connect it, you see a red mark. This is because the type is not matching. Side index number is an integer, whereas the input here is a string. I will disconnect it, and in between these two, I will press Shift A, and in search, I will search for the node value to string. You have a node value to string. I will drag the side index to the value here. This string output, I will connect it here. This string has number, and I am getting the name from here, and when it joins together, the value whatever I am going to get, I am going to connect this to this new row. So now this name is obtained. So if I hold it here, you can see the new name is new underscore rot 0. 0 is added automatically. This new underscore ROT, I have also used in this named attribute. So I will drag this output, and I will also connect it here. Also, I am using this new row again here when it is connected to this old row. So here also, I will drag and connect it to this, so that at all the 3 places, the name new underscore ROT will be new underscore ROT 0. I have done this for one variable. Now same thing I have to do for other 2 variables. So I will select all these 3 strings used to create dynamic variable name. I will drag it up, and I will press Shift D and move it down. Instead of new underscore ROT, I will now call this as old underscore ROT, and again from side index, I will collect it to value of this value to string, and now this old underscore rot becomes old underscore ROT 0. I will take this output, and I am going to connect it wherever I have used old underscore ROT. So I will drag it and connect it here in the third named attribute, and also I am using this old underscore ROT in the subtraction. So I will drag it and connect it. Then again I will select with shift press these three nodes, shift D to duplicate it. I will place it down and I will now call this as diff underscore ROT. I will drag this side index value and connect it to this value to string. I will take this output and I will connect it to wherever I have diff underscore ROT. So I will connect first here in the second stored name attribute, and also I am connecting it to this rotate instance. So I will drag it from here, and in this rotate instance connected named attribute, here also I will connect it to diff underscore ROT. So if I hold it here, instead of diff underscore ROT, it is now diff underscore ROT 0. We have created variable name and dynamically we are adding the side index value so that this variable name is different for different side index. I will go to file, choose save as, and I will give this the name as 3 underscore Rubik underscore cube, and I will click on the save button. Now I will come back to Rubik cube. I will press Ctrl space to minimize geometry nodes panel. I will go to file and save it, rewind it, and now if I play it, if I change the first rotation, you can see the rotation is working fine. If I set it to 4, it rotates 45 degrees. So I will make this 0 and I will check the next one. I will set this to 4. So you can see the middle one is rotating. I will set this back to 0, and the third one I will set the value to 4 and check it. So the top one is rotating. Then I will set this back to 0, and for the fourth one, if I change it to 4, see now the problem is all of this are rotating only along the z-axis. However, I want 2 of them to rotate along the x-axis, 2 of them to rotate along y-axis, and 2 of them to rotate along the z-axis. I will set this rotation back to 0. I will stop the playback, rewind and come to frame number 1. Now for all the 6, I have the same group repeated for all the 6, and now I want to make these groups unique. If you come here into the first z-axis, you see a number 6 here. It means that this instance of this group is used 6 times here. If I just click on this number 6, what happens is this became a unique group. You can automatically see it is called as z-axis.001. I will come into the named attributes. I select the second attribute, press tab, open this side panel, and in the name, I am going to give it the name as y underscore axis. Press enter. I will press N to close the side panel. Press tab and come back. You can see that only this is z-axis.001 and all other names have changed to y-axis. And you can see 5 instances here. I will select the first named attribute. Press tab to open it. Press N to open the side panel, and I am going to call this as z underscore axis. Press N to close it. Press tab and come out from the group. You can now see this has z-axis name, whereas the other 5 has y-axis name. Z-axis is working fine. I have no issues. I will select the second node which I have named it as y-axis. Press tab to open it. And in this case, if you come here into the rotate instance, we have combined XYZ. I am now going to drag this attribute, named attribute, and I am going to connect it to Y instead of Z. And also I will come to the top here. When you make the selection, I am going to come here and after sample index in these 2 separate XYZ, when I test the equality, instead of testing the equality of Z, I will connect Y here and also Y to A. So I have connected Y to A and Y to B. In place of Z, I am using Y. I will press tab to come back to the original group, and you can see here for z-axis I have set the index value to 0. For y-axis I have set the index value to 1. And for the third one, that is side index 2, I will change this again to z-axis. And now for the side index 3, this has been set to y-axis. This is fine. However, for the last two, that is side index 4 and 5, this should be x-axis. I will click on the number 4 here. When I click on number 4, this became now y-axis .001. Now I will press tab to open it. And in this case, I will press N to open the side panel, and instead of y-axis, I will call it as x_axis. In this case, instead of connecting y to A, I connect x to A from this separate xyz after sample index. I will also connect x to B here. So we are testing whether the two x-axis are equal now, and I will scroll down. With middle mouse clicked, I will scroll down and in rotate instances. Now in this case, instead of connecting this named attribute, which is diff_row, I am going to connect this to x. I will disconnect y. So with this changes done, I have called this as x-axis. Now press tab to come out. So for index 4, I have set it to x-axis, and for side index 5 also, I will set this to x-axis. So there are two instances of this group. So the order is, first I have z-axis for side index 0, y-axis for 1, z-axis again for 2, y-axis for 3, x-axis for side index 4, and again x-axis for side index 5. I will go to file and I am going to save it. Then I will rewind, and now if I play and check my Rubik cube, when I work with side index 0 and when I rotate it, you can see only the bottom layer is rotating, and I have to rotate it exactly by 8 values to rotate it by 90 degree. Then for side index 1, when I rotate it, you can see it rotates on the y-axis here. I will also rotate it exactly by 8 to rotate it 90 degree. Then for side index 2, you can see the top layer is rotating. I will also rotate it by 8 value to rotate it correctly by 90 degree. For side index 3, if I rotate, you can see the backside end is rotating. I will set this value to 8 to rotate it by 90 degree correctly. Then for side index 4, you can see that along the x-axis it's rotating, and if I set it to 8, it rotates it by 90 degree. Finally, for side index 5 is also in x-axis. If I set it to 8, it rotates by 90 degree. The entire rotation logic of my Rubik cube is working perfectly. But only thing you should remember is these rotations should be the multiples of 8. I will set all these rotations values back to 0. So I select all and I will set it to 0, and then I will stop the playback, rewind it, I will go to file and I will save it. We have successfully made it possible for us to rotate the Rubik cube along the 6-axis using our geometry node. With this, I am going to conclude this session, and in our next session, we are going to work on textures to add the correct textures on the 6 faces. And this we are going to again do it using geometry nodes in our next session.